All right, we're about to jump into a really powerful tool that has, frankly, an awesome name, orthogonal matching pursuit. Now, I know it sounds super complex, but it's actually a brilliant way to cut through all the economic noise and figure out what's really going on. Let's dig in.
So let's just start with the biggest question of all. When you look at the economy, what's actually pulling the levers? Is it interest rates? How confident people are feeling? A new government policy? The truth is, it's unbelievably hard to separate the important stuff from all the other random chaos happening in the background.
Here's how we're going to tackle this. First, we'll talk about the main problem, the signal versus the noise. Then we'll see how we have to prep the data. After that, we'll check out a simple strategy called greedy pursuit. And finally, we'll uncover the orthogonal advantage. That's the part that makes this whole thing so special. Okay, first up, the signal and the noise. This is, without a doubt, the biggest hurdle in economic forecasting. You're dealing with this messy, chaotic mix of literally thousands of variables, all changing at the same time. And this chart really tells the whole story. The true signals we're trying to find, the actual causes of things, are often tiny. They get completely swamped by predictable things like holiday shopping sprees, and then just pure, random, unpredictable noise. Our entire job is to somehow fish that little signal bar out of that giant ocean of noise. So, how on earth do we find that tiny signal? Well, we can't just dive right in. The very first thing we have to do is prep our data. We need to create a clean canvas before we can even think about starting our analysis. We're working with something called economic time series. It sounds technical, but all it really is a story told through data points over time. You know, like the monthly unemployment rate numbers or the quarterly GDP reports. Each new data point is like a new chapter in the story. Now, before we hunt for clues, we have to get rid of the obvious stuff. Step 1 is to deseasonalize. That means we mathematically erase those predictable patterns, like the huge jump in retail sales every single December. Step 2 is to detrend. Here, we remove the slow, long-term drift, like an economy just naturally growing over many decades. What you're left with is the interesting part, the wiggles and surprises that we really want to understand. All right, our data is clean, it's ready. Now the real hunt begins. We're going to start with a pretty simple strategy called a greedy pursuit. You can think of it like a detective showing up at a crime scene and just immediately grabbing the biggest, most obvious clue they see. The algorithm starts with a whole lineup of potential suspects. All these different variables like interest rates, consumer spending, you name it. Any of them could be the one driving our economic story. And here's where the greedy part comes in. It doesn't try to solve the whole mystery at once. Nope. Instead, it just asks one simple question. Out of all of your suspects, which single one of you, right now, does the best job of explaining the data I'm seeing? And boom, let's say it scans everything and finds that interest rates have the highest correlation score, a 0.78. Perfect. The algorithm greedily snags it, says you're the most important piece of the puzzle so far, and then it moves on. But here's the catch. There's a big problem with this simple approach. After it locks in on interest rates, it looks at what's left over, the part of the story it still can't explain. We call that the residual. And that leftover data can be really misleading, because picking interest rates first might have totally skewed how important everything else looks. Our detective grabbed a clue, but they didn't stop to think about how that clue changes the whole case. And this brings us to the absolute best part, the orthogonal advantage. This is the secret sauce. It's the brilliant mathematical step that fixes the big flaw in that simple greedy approach and makes this technique so incredibly smart. So here is the crucial difference. A simple greedy pursuit finds a variable and just moves on. It locks it in. But an orthogonal pursuit is so much smarter. After it picks a new variable, it actually goes back and reevaluates the importance of all the variables it has already chosen. It's constantly refining its theory with every single step. Think about our detective again. This is like them finding a new piece of evidence and then going back to re-interview every single suspect in light of that new information. They're not just collecting clues in a line. They're constantly rebuilding their understanding of the entire case. Because of this reevaluation, you don't get stuck on an early wrong idea, and the final picture is just so much more accurate.
Okay, so we have this really clever algorithm. That's great, but what's the point? Why does this mathematical magic actually matter in the real world? For businesses, for governments, for all of us?
Because the end result is something wonderfully simple and incredibly useful.
Orthogonal matching pursuit doesn't just give you a messy list of factors, it gives you a clean, ranked list with importance scores. It can tell you, for this specific economic question, consumer spending is the #1 driver, with a score of 0.65, followed by interest rates, and so on. It gives you focus. It tells you where to look.
So let's just wrap it all up. We know economic data is incredibly noisy. We also know that cleaning it up first is absolutely critical. Then this smart algorithm, OMP, comes in. It greedily finds the best clues. And then, this is the most important part, it uses that orthogonal step to constantly reevaluate everything to build a truly accurate model. And the result of all that work? Clarity. And that leaves us with one final thought. Having a tool that can so clearly point out the real levers of our economy is a massive, massive step forward. So the next big question is, now that we know, what do we do with that knowledge? How do we use it to build a better, more stable future?